So is there like specific questions that you guys want to ask, or do you guys want to cover the protein?
So pH is less than pKa, it deprotonates.
It protonates.
Protonates.
pH is less than pKa, it protonates.
Okay, that makes sense.
Yeah.
And then if pH is greater than pKa, it deprotonates.
It deprotonates. It loses that hydrogen.
Okay. Okay, and then for arginine, why are you looking at the alpha amino and the R group?
We're only looking at the amino and the R group because carboxyl group is making a bond with the second amino group's carboxyl group. Actually, amino group, if that makes sense. Because we have amino group, carboxyl group of the same amino acid, right? Then we move to the second amino acid to make a peptide bond. Since we have amino carboxyl, it goes to amino carboxyl, amino carboxyl. It starts with amino group and ends with carboxyl group. That's how the side chain goes in a long line.
So you want to look at what it starts with and what it ends with?
You want to see what it starts. The way you arrange your amino acids in a line, you want to start with amino group and with carboxyl group, because that's how they make a peptide bond. And when you have that done, then you look at their side chains and their pKa values and compare it to what you're given. Like the first one will be the amino group and then the R group. You'll look at both of them and give them a charge, if it's going to be +1 or +2, depending on the pH and pKa values.
Okay.
Does that help?
Maybe what about for like the next one, the SER? Like how would you analyze that one?
For that one, since it's in the middle, both amino and the carboxyl group are making a bond, so you only look at the side chain. Because they're already coordinated.
On this chart, you would only compare. I don't know, that's kind of confusing now.
Okay, let's see if I can find a video for you guys. I think that would be helpful.
Because for arginine, you're looking at 2 numbers, but for what is it?
Serine, right?
Serine, you're looking at 1 number?
Yes, because it's bonded to both sides. It's making a bond at the carboxyl group and the amino group.
And then so, okay, so then, but since you're looking at the side chain, I don't know. It's not really making any sense because I understand the arginine then, but I don't understand the serine now.
Okay, let me wait a second.
Shoot.
Okay, let me share this video. Let me share the screen so we can watch the video together. Does that help?
I didn't hear it.
You guys couldn't hear it?
No, I thought you were adjusting it. I couldn't hear. I don't know.
That's weird.
I can look it up though.
Yeah, because the one thing to keep in mind, it's, like I said, we're starting with an amino group when we make peptide bonds, right? We start with an amino group, and then the next thing would be carboxyl group, right? Because as an amino group, carboxyl group, and side chain. And then carboxyl group makes a bond with another amino acid from a second amino acid.
Okay.
Same thing goes on. Then carboxyl group from the first amino acid makes a bond with amino group of the second amino acid, and then carboxyl group of the second amino acid makes a bond with the amino group of the third amino acid. So it goes carboxyl amino, carboxyl amino, carboxyl amino. Starts with amino though.
Okay. But for each amino acid, they're different at different pHs.
Mm-hmm.
Okay.
Depending on what their amino, like their alpha, like their, let me see. Depending on their pKa values and what's given, either it'll gain +1 charge or it'll be -1 charge. Like we looked at arginine, right? Since it was pH was less than pKa, then it protonated, it gained that +1 charge.
You said arginine, right?
Arginine, yeah.
Okay.
So you're supposed to do that for every single one of the amino acid and add or subtract and get the final answer.
Okay. Is there something? Yeah, I guess that's what we would have to look at, huh?
Mm-hmm. Because I'm pretty sure he's not going to make you guys memorize all those numbers.
Yeah.
Those are a lot. Yeah.
Okay.
And what do you guys think about number 10? It says, which of the following amino acid is in zwitterion at pH 7? So which ion? So what is a zwitteron? What is zwitteron? What is that?
Negative.
Yep, amino acid having a positive and a negative charge, right?
Yeah.
And does only certain amino acid have that in their transition state, or all of them does?
All of them.
Oh.
Yep. That was the answer to that. And which amino acid has a sulfur group and makes a disulfide bond?
Cysteine.
Cysteine, yep.
Does he ask questions like that, or does he make it more difficult, or I don't know? Do you remember his exams?
For my class, we had a question about the formal charge. It was I think it was like 8 or 9 amino acid long chain, and we had to determine the net charge for it. There will be Henderson-Hasselbalch problems. I'm not sure if he's going to do the ice table again or not, but you guys should do definitely like practice more. Practice, practice, practice. if there's a change in volume, if it's a buffer and he's adding more and we're making either more acid or base, you know that you're gonna have to do the ice table. That's a hint.
Yeah.
And how would you do number one? What is the pH of a solution of 0.02 molar HCl? How would you determine a pH value when you're given with molarity?
0. What?
0.02 molar? That was like number one.
I don't have a picture of it,
Okay.
but I think we did, I'm trying to think of that equation just without referring. Is it, oh crap.
So how do you determine a pH value when you're given with H plus concentration?
pH equals negative log H plus,
Yep. So
right? pH equals negative log H plus. So H plus is the 0.02.
0.02 molar.
Okay.
Because it's HCl, that means H and chloride, they have same concentration of 0.02. So we can say that hydrogen is 0.02.
Yeah, I understand that. I feel like it's the one when they're kind of linked together that I'm having trouble with because there's no, I do good with steps. And I feel like with that one, I don't know where to start. Do you see what I mean?
Oh, the one with the net formal charge?
Yeah, with the net charge, like where, even if we're looking at arginine, like where do I start to find the answer?
You would start with, let's see.
The alpha carbon? Or with that, the alpha carbon and then that amino that's to the left, I'd start there.
You would start there.
And then I start counting, but where do I go to where I know which one changes? You know what I mean?
So when you see either it's going to be like NH3 plus, right? When it's NH3, let's say that's part of the amino acid and has a pKa value of 9. And we can find
because
that.
you have it labeled, yeah, or no?
It won't be labeled. You need to know if that's an amino group or carboxyl group just by looking at it. And if it's an amino group, you go to that chart, look at the pKa value, and then compare it to your pH. And either it's going to be +1 or -1.
But I should look for the NH3 versus an NH.
It could be NH3, NH2, or NH, depending on the amino acid.
How far do I, that's what I'm getting confused about. Like, how far do I count? Or do you see what I'm saying? Like, I don't.
No,
It's a
because.
medical group.
That makes sense.
Wait, what did you say, Abram?
Like,
I think
maybe if you can pull up like one amino acid and show me where you're stopping and where you're starting.
You don't have to count the whole thing. Just look at the amino group. If it's NH3, and is it going to gain a hydrogen or lose a hydrogen when pH is more or less than pKa? That's all you're looking at.
It can be that first NH that you see then, right? That's to the left that you can refer to.
Mm-hmm.
Okay. But wouldn't it have to have a pKa there? He would have to put it there, right? Or
He's going to have to give you guys a pKa unless he told you to memorize it, but I don't think he ever would.
okay, that makes sense then.
Yeah. Either he'll give you the pKa value or he'll give you the chart. You're going to have to find the pKa value on the chart, like we were looking at earlier.
Okay, that makes sense.
Okay. Does that help for all of you? Yeah. What else do you guys want to cover? I think by looking at that one particular problem, I would say he wants you guys to memorize sort of the structure, how it looks like, know how it looks like, because that'll really help you. Because you're gonna have to kind of draw it out for yourself to do that part.
even if, yeah, I don't know. I don't know what he's giving us because he said we don't have to memorize them, you know, acids. But then the SI tutor was saying he's gonna give us a blank sheet of like, well, not blank, but I don't know if he's gonna provide the structure or just the names and the three-letter code.
So I would say ask him to clarify what will be given on the exam and what will not be, so you can study for it. We can always practice on online session.
Yeah.
Anything else you guys would like to cover?
Do you have any mock exams or anything? Like any like reference papers or something?
Mock exams, no. But if you go, I can send you guys through a link that's like a tutoring website. So if you go there, I think there's some stuff for 150. If it's not there, we'll try to upload it.
Okay.
Because this is like more of one-on-one. It's like a tutoring session, so you guys can ask me any question you want to ask, or we can like understand a concept that you guys don't understand. So it's more like a tutoring based.
Okay. What time do you do in person? Like do you do it in the basement level?
In the basement, yes. So on Mondays I do 1 to 3. On Tuesdays I do 11 to 3. On Thursdays I do 11 to 3. And then on Fridays I do 10:30 to 12, and then 1 to 3. You guys can find my schedule online. If you go to the tutoring schedule, like Fresno State Tutoring Learning Center, you can find my schedule there.
Okay.
Yeah.
Okay.
Either type in Chem 150 or type in my name, Praveen. It'll pop up.
Okay, so tomorrow you're gonna be there 11 to 3, right?
Tomorrow it's, yes, I'll be there 11 to 3.
Okay.
Yeah.
Yeah, I'll be there.
Cool.
Yeah.
Well, it was nice meeting you guys.
You too, thank you.
Bye.
All right, have a good night.
You too. Good luck studying. So it starts with certain group, right? Then it ends with certain group. What are those terminals? What are they called?
And terminus. And I don't know the other one.
And does anyone else know? So it starts with amino group, right?
Mm-hmm.
What does it end with when it makes a polypeptide chain?
A carboxylate group.
Carboxyl group, yeah. So the way they make a bond, it's amino acid, like carboxyl group of the first one making a bond with an amino group of the second amino acid. And then so it goes on. And what happens in the secondary structure? Anyone?
I've written down like alpha helix and beta sheet and loop and all that.
Yes. So there are two different type of interactions, right? Alpha helix and beta plated sheets. What are alpha helix?
Coil shape.
And in what direction do they coil? To the right or to the left?
Right?
To the right. So it goes like this in the right direction. And what's beta pleated sheets? How many types of beta pleated sheets do we have? There are two. Do you guys know what they are?
I don't.
Okay, so there's parallel and anti-parallel. What do you guys think when you listen to the name parallel or anti-parallel? How do you think they make a bond together?
Parallel, they just don't touch.
So parallel, it's like they have N-terminal and N-terminal on the same side. And if it's anti-parallel, it's like N-terminal on one side and C-terminal underneath it. So they're opposite from each other. And what's the bond between them?
In the anti-parallel?
What's the bond that keeps them? I'm sorry?
OH bond?
OH bond, I don't think that's a right name, but yeah, it's hydrogen bonding.
Yeah.
Yeah, so it's like hydrogen making a bond with another hydrogen, right?
Mm-hmm.
And what happens in tertiary?
It finalizes into a 3D shape.
Yep, it finalizes the 3D shape. And quaternary?
Multiple protein chains.
Yep, multiple tertiaries combined together, right?
Yes.
Okay. And do you guys know how to do the charges for amino acids since you guys have exam tomorrow? That was on I think the study guide question.
No.
Okay.
Is that like how we figure out if the pH is bigger or smaller than okay.
Yes. Do you guys feel comfortable with that or no?
And there was one of them that was neutral, and I didn't understand why.
Which one was it? What study guide was it again? I can pull that up.
But maybe it was just an example we did in class. I don't know. It's okay. It's okay. It was just the pH was 8.
Mm-hmm.
The pKa is 6 for H. It's for his.
Okay.
And then that one, he said it was neutral, and I didn't get why, because 8 is bigger than 6 for the pKa, so I thought it was negative because it's depronated. Does that make sense? But then he put neutral, so I'm like.
Was there another group, like a carboxyl or the side chain that he looked at?
The side chain, it says his, and then R, and then NH3+.
So I think he might have said neutral because if you have a plus and minus on the same chain, then it cancels each other, so it becomes neutral.
Okay. That makes
Yeah.
sense. Okay.
Mm-hmm.
I don't remember what question it was, but we had a quiz online, and I thought the answer was +2, but it ended up being +4.
I remember that one.
Are you in Brooks's class too?
Yes.
Okay. I think I have the you guys only took one quiz, right?
Yes.
Okay. I have the question. Let me pull it up really quick.
Oh yeah, it's the net charge of the following peptide at pH 1.
Mm.
What number is it?
7.
So let's do it on here. So what's the first amino acid that we have on this particular chain? So the question is, what would be the net charge of the following amino acid at pH 1?
Mm-hmm.
And the first amino acid is arginine, right?
Mm-hmm. Yes.
And do you guys want to kind of work it through while I set my iPad with it? I can share the screen with you guys.
So arginine is a plus, right? +1.
What are the pKa values for arginine?
Oh.
Because I don't remember them from top of my head. pKa values.
I'm trying to remember which PKA, because there's 3 PKA.
Let's do it this way. Here are the pKa values.
Yeah.
And the first one we're looking at is arginine, right?
Mm-hmm.
Which is right here. And what groups are we going to look at for arginine? No, that's asparagine. What groups are we going to look at for arginine when we look at the charges?
What do you mean by what group?
Yeah, I don't understand.
Because the way we draw them, it's an amino group. There are 3 different parts to arginine, right? There is an amino group, there is an R group, and there is an alpha group. Amino group, carboxyl group, and R group, sorry.
Mm-hmm.
Are we going to look at all 3 when we determine the charge? 2 or only 1?
1.
Why would you say 1?
Or is it 2? The amine group?
If it's 2, why and which ones?
It might be 2 because there's 2 amine groups connected together.
So the way it works, we have arginine, right?
Mm-hmm.
It's making a bond with lysine. That's the next amino acid in line, right?
Okay.
No, actually it's serine. So it's the carboxyl group from arginine is making a bond with an amino group of serine. So we're going to only look at the R group of arginine and the amino group of arginine, not the carboxyl group, because that's already making a bond with another group. So it can be protonated or deprotonated.
Okay, so for arginine, we're looking at the R group of it, you said.
Yes, we're looking at the R group and the amino group.
Okay.
Do we have to do that thing where he said in class, like in the beginning of all of these, the NH3+, like we have to have that, and then at the end it's the
carboxyl group, yeah.
And so then do we, for those ones, we look at pKa, the second row, right? pKa.
Do you mean for the last one?
Like for the very first one.
For the very first one, you look at the pKa of 2.
Yeah.
And pKa of 3.
The rest, it's like whatever is only on the third one, right?
Yeah, for the middle ones, whatever is on the R group, yes.
Okay.
The side chain, yeah, which is the pKa 3.
Okay.
Yeah. you guys got the pK values?
Okay, yeah.
Okay. So what are the pK values and what's the charge?
For the first one, would it be 9.04?
The first one is 9.04. And what's the second one that we're gonna look at?
Oh, the second one that we're going to look at. So 4.25.
Wouldn't be 11.48 because that's a pK value of the side chain. So we have arginine, right? And here's the amino group. And then the R group. And serine. And the pKa value of the R group is, let me see. And what's the pK value of the amino group? 9.4. And is pKa less than pH? Or pH less than pKa?
It's more.
And when pH is more than pKa, it deprotonates, right?
Okay.
And that means, is it going to be +1 or -1?
Maybe plus.
When it's deprotonated, it's minus.
Oh.
So it would be -1. Because we're looking at pH 1. Since it's less, that's...
Okay, so it was +1.
Yeah. Since pH is less than pKa, it's protonated. So it's +1.
Okay.
And for the R group, is that more or less than pH?
It's more again, so it would be +1 again.
And +1.
Okay.
And for serine,
How did we get the R group pKa? Sorry.
this was the third pKa value listed in the chart. It will be given to you on the exam.
Okay.
Yeah. And then after serine, we have...
Oh,
And the one thing to keep in mind, the middle one, we only look at the R group. Do you guys know why?
Because their terminus are connected to the rest?
Yes. So what is the pK value of the R group of serine?
it doesn't have one.
Yep, it doesn't have an R group. How about for GLN?
Which one's GLN?
It does.
This one is glutamine.
No, it doesn't have one either.
It doesn't have it either. Perfect. And what's the next one?
3.65.
Is it 3.65? Yep. And is that more or less than pH?
It's more. It's 4 plus 1.
Plus 1. And after aspartate, we have lysine.
So 8.95 for that person.
And what's the pK value of lysine?
8.95 for that first one. For the R group, right?
For the R group, would it be 8.95 or 10.53?
Oh, 10.5.
10.53. And what would be the charge for it?
+1.
Plus 1. And for the last one, what are the two groups we look at?
The R and what was it? Carboxyl?
Carboxyl.
Mm-hmm.
And what would be the charge for the R group?
That would be the one that's 8.95. Right?
This is still 10.53 because we're looking at the R group.
But for the carboxyl, that's the.
For carboxyl, it would be 2.18.
Oh.
8.95 is the amino group. Since this is 2.18, what's the charge for it?
It'd be positive. Is it neutral?
Wouldn't it be positive? So we get 1, 2, 3, 4, 5, 6. And you said the answer was 4?
Mm-hmm.
It might have been, or maybe I thought it was 4.
It is 4. But I think that doesn't that carboxyl it's positive, but then doesn't it cancel with the negative? Like I don't know.
Because even for the R group, it's 10.53. Which makes it positive. One, 2, 3, 4, 5, 6. How does he get +4? Because this is the math that you're supposed to follow. Look at the pH and compare it to the pKa, and either give it a plus or minus charge.
Does the pH 1 do anything? Like if they give us a different pH to...
If let's just say if it was, they gave you pH of 9, right?
Mm-hmm.
And since this is, in this case, the pH is
Oh, okay.
more than pKa, so
Mhm.
it'll be -1.
Okay, I see how it changes now. Okay.
Yeah. So that'll help you to determine if it's gonna +1 charge or -1 charge when you compare both of them.
Okay.
Yeah. I think we got all them.
Okay.
So then what's the answer?
I'm getting +6.
That one wasn't one of the options, I don't think.
That's why I'm double checking. Because that's 3.65. 10.53.
I wonder if that last one negatives for some reason.
But why would they be negative?
Because they're box, I don't know. It's like COO minus, isn't it?
Hi, Karen.
Because we pH is 1 and pK is 2.18. That makes it positive.
Do you know if it's all going to be multiple choice or if we have written ones too?
I feel like it's a mixture of both. Yeah. That's how it was for me. But this is a method you're supposed to follow. I'm not sure why he's getting +4 instead of +6.
Quick question about the protein structure.
Mm-hmm.
Do we need to like, other than what we went over, what else do we need to know? Like, how much in detail would we have to know?
I would say for him, just know whatever he said in lecture and what's on the PowerPoint.
Okay.
Yeah. Because from what I know, he won't give you anything outside the PowerPoint.
Okay.
Yeah. He must have told you guys not to use the book, right? Did he?
I know. I haven't looked at it.
Yeah. What else we can do? And what's the amino acid that can be protonated or deprotonated at pH 7? You guys know?
Can you repeat the question, please?
So what amino acid can be protonated or deprotonated at pH 7?
All the amino acids.
There's a special one.
What?
It works both ways. It can be protonated or deprotonated depending on how it's supposed to be in order to stabilize the substrate.
Is it ASP or glue? Glycine?
No.
I have two notes actually, and one for,
What amino acid is this?
oh, it's histidine.
Histidine. That was one of the quiz questions,
Yeah,
right?
I will see right now on my notes.
Yeah.
What's the one that can be pronated and depronated?
At pH 7. And how do you know if something's an acid or something's a base?
Based on their charge.
Can
If
you
they,
expand? Can you expand on?
sure, if they carry a positive charge, then it's base. If they carry a negative charge, then it's acidic.
That's true in some scenarios, but let's just say we have these two. Which one is an acid and which one's a base? Or acid and a conjugate base?
First one, it's acid. Second one is conjugate base.
Yep. So keep in mind the one with more hydrogens will be your acid. And conjugate base, it's after it's lost either 1 or 2 or 3 hydrogens.
After it's lost hydrogen?
Yep. Because when we do a reaction, acid reacting with base, it forms a conjugate base and a conjugate acid, right? And acid lose the hydrogen and base gains the hydrogen. Yeah. And what else is on your guys' study guide?
I want to go over the diagram if someone confused with me too about the BKA1, BKA2. There is a question on a study guide. Let me just pull.
What study guide's that?
For second study guide for the BKA base acid study guide.
Is it 1.2?
No, it shows us the diagram and then it tell us like what is going on in BKA1, BKA2, BKA3. Have someone remember it? It's something like this. Something like this diagram.
Oh.
I had it, but I don't know where.
And like when you find like that isoelectric point and stuff like that?
There is a question on study guide, yes, for base acid questions. I didn't know how to answer it. Just give us diagram and then I'm pretty sure he will include this in the exam because he said he will include a diagram, like a curve diagram, and will ask us what is going on in BKA1 and BKA2.
And he'll give you the amino acid, right?
I think so, yes, he will give us the amino acid.
Is that?
Oh,
Wait,
study guide 2 where it says draw the titration curve for the amino acid aspartate, clearly indicate where the 3 pKa points and the
Yes.
in the curve.
Yes,
Yeah,
exactly.
Either, actually.
I didn't know how to answer it though. I kind of go over the study guides.
For that kind of problem, I would say look at this answer key. This one. See at the first point A, let's just say, it loses a hydrogen from the carboxyl group.
Mm-hmm.
And then at B, it loses the hydrogen from right here.
Why those two exactly? I mean,
Because this is the, when the reaction starts, it's acidic, right? It's gonna attack the acidic group, the carboxyl. And in the intermediate steps, it's gonna attack the these three ones. It's KB, it's like basic.
okay. And K3, I mean part C.
Part C is K constant. It's deprotonating the carboxyl group again. It says right here, Ka, that means it's highly acidic. Ka means acid.
I haven't my guards caught these intruders yet.
Mr. Oliver, do you sell clam chowder?
And it loses the hydrogen from the carboxyl group. And then it lost, see how you put this right here? You're losing a hydrogen from these three.
And me on a 1,500 calorie a day.
From each group, one hydrogen, like basically I'm losing 3 hydrogens. Or just one of those things will lose 1 hydrogen.
I would say, I want to say it all happens at once.
And the rest 2 will keep their protons with them?
Yeah, because like at point B, the amount of reactant and amount of product is equal. So whatever you take off from the one side, it'll be given to the other. So if you take all 3, don't forget that you want to draw all 3 for the products too. And then at case C, that's when the final step happens. K constant. Does that answer your question?
Yes, I'll go over it again. I'm just feeling confused about the diagram itself. So I'm gonna go over it again and see if we can.
Okay, they just want to know what happens like when it's highly acidic. Right now there's a pH of 2, right?
Yes.
What group is it gonna attack? Oh, attack the carboxyl
The
group.
acidic.
And then at B, it'll attack this. And then at C, it most likely to gonna attack the amino group.
What about if you give us like a different amino acid?
If you think about it, they all have 3 chains: acidic, basic, and R group, right?
Yes.
So at the first one, if it's a very low pH, then it will attack the carboxyl.
So the OH here is the R group, right? And P. Point P.
Yeah, this is right here. This is a carboxyl group.
And point B, it's the R group. Okay, cool. Thank you.
You're welcome.
Does it always start attacking the, the amino group?
Start with it or end with it?
Either or. What would it attack first?
It'll go with the carboxyl group.
Okay, first carboxyl. Okay.
Yeah, because if you look at this equilibrium equation at the top,
Oh, okay.
it deprotonates the carboxyl group.
Okay.
Yeah. And I'm not sure how he's going to test you guys on the protein structures. So, any questions about that part?
Have you taken this class before with them?
I took 155A with him.
Oh.
Yeah. It's pretty much similar, but I think there's a little bit more stuff that you guys covered than us towards the end. Yeah. You guys go in more depth.
Bad for us. There is something I highlighted. It's oligomer when it's two on the subunit protein chain. When I said heteroterms, two beta and then two helix. Do someone do this too? Or just me?
I don't know which one you're talking about.
It's on my. Oh, okay. Never. Sorry, never mind. I'm looking to the wrong one. I'm looking to the fourth structure. It's not included in our exam.
But the quaternary structure is not included?
I don't think so. No.
Okay. And do you guys feel confident about the PI? Isoelectric point?
Formula for it, pKa plus pKa over 2.
Yes.
But what are the two pKa's? That, like, is it on the curve?
The pK value is the way you want to pick. If it's a neutral atom, then you do the two pK values are very close to each other. If it's an acid, like an acidic group like aspartate acid or glutamic acid, then you do pK value of the R group and a pK value acid group.
Okay.
If it's basic, then you do a pK value of the R group and a pK value of the basic group divided by 2. Every time it's divided by 2.
Is there like an example that we can do?
Yeah. So what would be the PI for lysine?
How do we know if it's neutral, acidic, or basic?
You're going to have to memorize those. If it's polar, non-polar, if it has a charge, if it doesn't have a charge.
Oh, memorize? Okay.
Memorize those, yeah. And pKa 1 for lysine is 2.18. That's no. And the other one is 8.95. And the third one is 10.53. So R group. This is your amino group. But here's your carboxyl. So what would be the PI? And how would you do it?
Since lysine is acid, it's base actually, sorry. And then I'm just gonna take the base values. 2 of the base values divided by 2.
So what would be the answer?
You said 10.5, 8.5, 8.95 plus 10.5 divided by 2.
Yep. And what would you get for an answer?
Actually, I don't have my calculator. Hold on, let me calculate it.
Did you say 8.95 plus 10.53?
Yes.
Yes. So the answer is 14.1.
You forgot to divide by 2.
I did actually, but I think Yes, I did. I got 14.1. This is
Yeah.
logic.
The answer should be 9.74.
974. Hold on. It's 8.95 plus 10.53 divided by 2.
Yeah, 974.
I don't know. I think I have something wrong with my calculator then.
8.95. Yep, it's 9.74.
Is there like a list that says which saying which ones are acidic and which ones are basic? Like a chart?
No,
But you can find images online.
With this, because he said this is going to be given on the test.
I think the only thing he'll give you, it's a chart just with pKa values and the amino acid name. He won't give you the structure.
I thought he said that he would give us like exactly this.
But that would be like, wait, can I see it? I mean, he's changing it then now. Yeah, then that's what he'll give you.
So we can determine with this if it's basic or acidic.
from their pKa, you will know if it's basic or acidic. Because if you know the pKa, you will know the charge. If you know the charge, if it's positive, then it's base. If it's negative, then it's acidic. Isn't it like that?
I just remember the chart.
Can someone send me the charge, please?
Okay.
Because this is a chart that I normally use whenever I want to study.
Oh, okay. Wait, let me take a picture of that. Okay, got it.
Because the plus charged ones are basic and the negative charged ones are acidic.
Mm-hmm. And then for the nonpolar and polar, would we have to get the PI for those?
Let's see. So these are the ones that have on our chain or the R group. There are only 5.
Oh, okay. So we just have to know those.
Yeah. You just have to know those.
Okay, got it.
The other ones are just pKa1 plus pKa2. You guys can either take a picture of that or write it down. That's fine. If you look at it, these 2 are acidic. These 2.
Mm-hmm.
And these are basic.
And if they're acidic, you add the pKa2 with pKa3, right?
For acidic, you add pKa1 with pKa3. Because pKa1 is carboxyl group, pKa2 is amino, and pKa3 is the side chain.
Okay. And then the basic ones are 2 and 3.
The basics ones are right here. Glycine, arginine, and histidine.
Yeah, but pKa2 and 3 is what you add.
Yep.
Okay. Got it. Okay.
Any other questions that you guys want to go over? Do you guys have to memorize the 3-letter words for the amino acid? The 3-letter alphabet? No?
No, we don't.
Okay. Any other questions for me?
Can you repeat what did you say, how we add BKA1 to BKA3?
Yes.
Thank you.
No problem. So if it's a neutral atom, you do the pKa1 plus pKa2 divided by 2. If it's acidic, then you do pKa of the carboxyl group with the pKa of our group divided by 2. If it's basic, then you do the amino group and then the R group. And there are only 5 that either requires acidic or basic. 3 for basic, 2 for acidic. Out of 20 amino acids, there are only 5 amino acids. And this,
I got
this
it,
would,
thanks.
this would be amino and carboxyl.
And then the last thing, the basic, is just the BKA of amino and then BKA of R. Is this R?
Yes, that's R.
Okay, cool. Thank you. Got
R
it.
group.
Can you go over question 4? I got it wrong the first time.
On the quiz,
Yes, on the quiz, please.
so the question is, you make a buffer composed of 1 liter, 0.1 molarity of sodium acetate and 0.2 molar of acetic acid. pK value 4.76. You then add 0.01 mole of NaOH. What's the pH? What do you guys think you're gonna do?
That's the one where you take the pKa and then add the the base over the acid, right?
That's a Henderson-Hasselbalch equation. Yes, we're gonna use that. But is that the first thing we're gonna do?
I'm not sure I got it wrong. So
when you're adding something, that means you're changing the volume, right? That means you're gonna have to do an ice table. Do you guys remember doing that part? Yeah, no?
Yes, kind of. I remember. Ice table.
So you have
The equilibrium table.
1 liter of 0.1 mole. I'm sorry? What did you say?
I said, is it equilibrium table?
You can say that, yes. Because in this one, we're adding something, right? We know our pK is 4.76. And our base is 0.1 moles. And our acid is 0.12 moles. If you plug it in like this, you'll get a wrong answer. Because the problem says that we're adding 0.01 moles of NaOH.
Okay.
So we know that we're reacting NaOH with acetic acid to form sodium acetate. And do you guys know how I got that equation?
I don't.
So they're telling us that in a buffer solution we have an acetic acid and sodium acetate, right? And we're adding NaOH. When we're adding NaOH, are we making more base or acid when you add NaOH?
More base?
You're making more base. So we're reacting NaOH with acetic acid to make more base, which is sodium acetate. And they tell us that there's 0.01 moles of NaOH. And acetic acid is 0.12 moles. And sodium acetate is 0.1 moles. What do you think is the change? What do you think the change is?
We will add 0.01 moles to the base moles, like 0.1 plus 0.01, and then we will subtract the same amount from the 0.12.
Perfect.
Okay.
And what do you get as the answer?
I don't have my calculator. Someone do it.
Okay, for acetic acid, you get 0.11. And for sodium acetate, you also get 0.11, right? And then we take these numbers and plug it into the Henderson-Hasselbalch equation. So the new equation would be
4.76.
This would be 0.11, 0.11. And when you take the log of this, what do you get as an answer?
0.
Yep, so it'll be the log of 1, which is 0. So 4.76 plus 0 is 4.76.
Mm-hmm.
So just remember, when you're adding something, you want to do the ice table, unless he tells you that there's no effect of the solvent added.
Wait, what's the ice table? This is the one you showed us?
Yes.
Okay, that's what it's called.
This is initial, change.
Okay.
I go with equilibrium, but some people go as final.
Okay.
That's it for today. Do you guys feel more confident for the exam now? A little bit
I
more
do.
confident? Okay.
Thank you so much.
Thank
You're
you.
welcome. You're welcome. Good luck on the exam.
Thanks.
Bye.
Bye.
Huh? Yes. Thank you.